one caveat, there is a leftover slide, sorry for that, it's my fault, at some point. And second caveat, I would be very, very short in time to do not, to leave space for the maybe most interesting part of the presentation, which is the actual work of the teams. So my name is Matteo, I work for Cinega, and I am in HPC since 3 years. I'm an alien in this world because I come from particle physics, so really I'm used with large infrastructures, but running a data center require, as you said, so from what Thomas presented, required a lot of competencies. And so I'm just helping the application developers to port the codes on the ARM. I'm just coordinating their efforts. Okay, just an introduction. Europe is a small territory. We have a long history, many good things in this land, but it's 1 century, 2 centuries that the world is becoming much more connected. And modern applications are actually workflows. A sequence of steps that could be optimized, maybe some benefits of, some special kind of accelerators, some benefits of some language. So in the global competition for computing, which at the very end produced services for our societies, Europe must find a way to stop buying machines designed in the US, and probably also mitigate the very rapid growth of the Chinese products. So Europe developed a few years ago a strategy for the exascale class computing. And one has been already introduced by Thomas, but it consists in architecture that can orchestrate complex application, modern application workflows in a heterogeneous environment, with this heterogeneous is declined at system level. So European supercomputer of the future will have multiple modules, each of them dedicated, specialized for some particular aspect. This is a change in which the hardware adapt to the needs of the software. And what we do in this project and in this application team is also try to adapt the applications to the hardware. So it's really a spiral somehow. And as it has been introduced, the European Union bet on the RISC architecture. Not going on, and this project is on ARM-based solutions. Okay, it's a small land compared to other continents, but it's pretty fragile. The demography of Europe, is indicating that in a few years we will be 1/10 of the world population. So, what to do with this? Very beautiful tradition. We invented the first universities, and we have to do something back to the world and also for us. So when the global warming is there, climate change, forecasting the weather conditions, it's of vital importance, not only to decide if I have to have the umbrella with me today, but also what happens to agriculture. Agriculture means food. So in EUPEX, in our benchmark grid, we have production level applications, for example, the integrated forecasting system, but also some new kind of workflow in which we try to help the agricultural field or sector in becoming more precise and transforming agriculture in order to be compliant with limited resources, which probably is the characteristic of the future, at least in Europe. Of course, we are very good in academic and pure research. So we have astrophysics application, I mean solid Earth studies, but also a new business. The Europe can, I mean, say a lot of things. Is monitoring the Earth from the satellites. Europe has a large program on it, and we are providing actually data for the entire human beings, which is very interesting. And we have an application called AI for Earth observation, which develop AI model to process the image data sets and extract value from this data. And there are other industries that could benefit, for example, the pharmaceutical, or the investigation for new materials, and as well as I mean traditional engineering, and some other applications and standard benchmark in the HPC world. This is the leftover. Let's move to this one. So in the recent, in the last year, we made a lot of steps in the direction of heterogeneity, both at node level, I mean the combination of a CPU and some sort of accelerator, and at system level, the modular supercomputer architecture that I mentioned at the beginning. More or less, three are the directions that we explored, or well, we improved the maturity of our application to exploit this kind of characteristic. So we started with application already optimized for scalable vector extensions, and also adapted to the high speed or high bandwidth memories in modern architectures. And in the last year and a half, more or less, we further optimized for ARM. For example, one issue was, is it better to manually vectorize my code, or I mean, the maturity of the current compilers is high enough that I can automatize the thing. The result depends on your actual code. What we did recently is to extend some source-to-source compiler. Somehow, I mean, the tool chain for compiling an application, and exploit these scalable vector extensions, so vectorial extensions. And of course, I mean, they try to exploit the many cores that are available in this architecture. And this is something common with other fields. I mean, outside from HPC, if you go consider automotive, for example, they have, I mean, 160 processors in the same board, so the same chip, which is a mess. And then, of course, I mean, the accelerator is the one for the AI. There is this GPU devices that offer tremendous speed for some applications, but we are in a situation of a monopoly. There is a player that is providing full stack solution, I mean, from hardware to software, to models. So, okay, we added AI in our workflows. We accelerate some portion of the computations using the seamed structure of the GPU, but we did it also having in mind that we must be open to different vendors. So, I mean, code portability, and we adopted not only the proprietary language, but also some other solutions that are more portable, let's say. What we have in front of us, the project is going to end in 1 year from now, and we have a second half of the workshop. So many of the things will be presented in great depth compared to my presentation. But what we plan to do, and I mean, this is something I'm really committed on, to produce a good final report on our application experience. Inside this project, this will have a public visibility. We will also introduce 2 new innovative workflows with confidential visibility. One is about precision agriculture, and the other is related with natural disaster recovery. And if you are curious, I mean, we already uploaded in the website some webinars. The reports are available, and also high quality papers, you can find that. So it's a good, and I hope that I mean some of the solutions or the investigation we did could be also useful in other fields different from HPC.